Magnetic dipole moment of a revolving electron. So when an electron is revolving around the nucleus, it is similar to the circular loop. The electron is revolving around the nucleus in an anti-clockwise direction. The current is flowing in a clockwise direction. There will be a current will be set up in the circular orbit. So the electron is flowing in this direction. The current direction will be in the clockwise direction according to Bohr atom model. So the velocity of the electron is in this direction. So this will be rotating in a circular motion. So whenever there is any particle is moving in a circular motion, we have a angular momentum L. Okay, so this is the angular momentum. So what we have studied, that circular loop has a magnetic dipole. This is similar to the circular loop. Electron revolving direction is this one, and the current direction is a clockwise direction. This is similar to the current loop. So this current loop has a magnetic dipole moment. That magnetic dipole moment direction is downward direction according to right hand thumb rule. So these things only we are going to see detail now. So V is the velocity of the electron, L is the angular momentum of the electron because of the circular motion of the electron revolving around the nucleus, and mu L is the orbital magnetic moment of an electron. So there will be a magnetic moment arise for the electron due to its current flow, because it is similar to the circular loop, small elemental circular loop, but this is arises due to the orbital motion of the electron. So we give the name orbital magnetic moment of an electron. So very simple, students. Electron revolve around the nucleus is similar to the current loop, which possesses a magnetic moment m is equal to Ia according to previous video formula, that m is equal to Ia. Okay, so current I is equal to charge by time. So the charge of the electron is E. The electron completing a one complete revolution means the time taken is a time period T. So velocity, which is equal to distance by time. So the total distance taken for completing one complete revolution is 2 pi r, and the time taken is a time period T. So 2 pi r T, that is T is equal to 2 pi r by V. Substitute this T here, that is I is equal to E V by 2 pi r. So the area of the current loop is area A is equal to pi r squared, where r is a radius of the orbit. So we have a I value, we have a A value. So substitute in m is equal to Ia. This m is a magnetic moment, is a orbital magnetic moment. We can write this m as a mu L. So mu L is equal to magnetic moment due to the orbital motion of the electron, or orbital magnetic moment is given by mu L, which is equal to I into A. So EV by 2 pi r into pi r square. We are cancelling the pi and r. We finally arrive the equation orbital magnetic moment mu L, which is equal to EVR by 2. So according to right hand thumb rule, we are having a direction of the magnetic dipole moment, orbital magnetic dipole moment. That direction is downward direction as it is shown in the picture. So the direction of the orbital magnetic moment is downward direction. The direction of the angular momentum of the electron is upward direction. So what is the angular momentum? The angular momentum of an electron due to the orbital motion is given by L is equal to mvr. M is the mass of the electron, v is the velocity of the electron, and r is the orbital radius. So the direction of this one is upward direction, as we are earlier told that. Okay, so now mu L by L, that is magnetic dipole moment, orbital magnetic dipole moment by angular momentum. If you divide these two things, that is called as a gyromagnetic ratio. So if you divide that, V and R are get cancelled, E by 2 me. This is the mass of the electron. So mu L by L is equal to E by 2 me. If you substitute the E value 1.6 into 10 power minus 19 and M value 9.1 into 10 power minus 31 kilogram mass of the electron, we arrive the number 8.8 into 10 power 8 coulomb per kilogram. This is the constant value gyromagnetic ratio. This may be asking one more question, keep in your mind. So mu L, you bring this L here. So in vector form, the magnetic dipole moment, orbital magnetic dipole moment is given by minus E by 2 mg L vector. So you may ask question, why sir this minus sign comes? This minus sign indicates that the orbital magnetic dipole moment and the angular momentum of the electron are in the opposite sense. So we have to put a minus sign here. Okay. So then, according to Bohr's quantization condition, angular momentum is equal to NH by 2 pi. But in mechanics, angular momentum is equal to MVR. But actually, in Bohr magnetism, in Bohr atom model, we have studied that Bohr gives a postulates, three postulates. That one of the postulate is angular momentum is equal to NH by 2 pi. So mu L which is equal to, so what we are having that mu L which is equal to minus E by 2 me into L. In this L, we have to substitute NH by 2 pi. So we get arrive an expression mu L which is equal to N into EH by 4 pi me. This is a magnetic moment of an electron in nth orbit. If you substitute n is equal to 1, that is the first orbit, that is for the hydrogen atom. So mu L is minimum. So if n is equal to 1 is mu L magnetic moment value. Minimum magnetic moment value is mu B, which is equal to EH by 4 pi mu. Substitute this H value, E value and ME value. We arrive the number 9.27 into 10 power minus 24. This is called Bohr Magneton. So Bohr Magneton is a unit of the measure unit used to measure the magnetic moment of an electron. So in terms of Bohr Magneton only, we are represent the magnetic moments of the different atoms or the electrons. So very simple students, we are arrived at what is that? Don't confuse with this. Just you take the electrons are revolving in the anti-clockwise direction, the current I is there. So we are derive the expression for I by using E, that is a charge by time. I is equal to EV by 2 pi r and area is equal to pi r square. Then simply we get an equation. M is equal to I into A. M is a magnetic dipole moment, that is orbital magnetic moment. We get an equation. So what we will have, this is a circular motion, so we have to include the angular momentum consideration also. So angular momentum of an electron is mvr. We substitute here, we get an gyromagnetic ratio. So instead of this L, if you substitute the Bohr quantization condition, means we arrive the Bohr Magneton equation. So don't confuse that, it is a small thing, but it is a chain. One by one it comes continuously in a logical way. So electrons not only revolve around the nucleus, it is also spinning itself. So the electron has a spin angular momentum S vector due to its spinning motion. So we can represent that similar to mu L vector, which is equal to minus E2 me L vector. Here we can represent that mu S vector is equal to E. These two will not come. So we get mg, mass of the electron, into S vector. This is the angular momentum of the orbital angular momentum. This is a spin angular momentum. So it is a spinning like this. Okay. So where mu S, which is equal to spin magnetic momentum, S vector is equal to spin angular momentum. So these two magnetic moments are arise for single electron. So we come to the conclusion, total magnetic momentum of the electron is a sum of the orbital angular momentum and spin angular momentum. So mu is equal to minus Ge by 2 me L plus 2s vector. This is the magnetic moment of an electron. So whenever the electron revolves around the nucleus in the inside the atom, it possesses magnetic moment. This is the origin for magnetism. So origin of magnetism comes from the electron's motion. Electron's motion is a revolving motion as well as a spinning motion. Without the electron's motion, no material will possess a magnetic property. So you may ask one question, certain materials are act as a magnetic material, certain materials are not at all a magnetic material. because the number of electrons plays an important role for determining whether the given material is a magnetic material or non-magnetic material. So for the magnetic material, the even it will be a unpaired electrons will must have. If the number of electrons, that is a total unpaired electrons are more, means the magnetic moments never cancel out each other. It possesses a magnetic property. For the non-magnetic material, there will be a paired number of electrons. So the total net magnetic moment will cancel out each other, and hence that material is a non-magnetic material. So that's I will explain how the material will possess a magnetic property. So this question is very important for origin of the magnetism in a matter. That's why this unit is magnetism and matter. So how the material will possess the magnetic property because of this magnetic moment, orbital magnetic moment and spin magnetic moment of an electron. So due to this property only, each and every material has a magnetic property. So this question is very important for magnetic point of view. Thank you, students.